Here are some facts about freshwater depletion. A few to pay attention to would be that 780 million people live without clean drinking water, and that is as of today. About 4.5 billion people globally already live within 50 kilometers of an impaired water source, so one that is running dry or polluted. And the last major thing to pay attention to is by 2025, an estimated 1.8 billion people will live in areas plagued by water scarcity, with two-thirds of the world's population living in water-stressed regions. So this picture is just a visual representation of what was mentioned before. As you can see, the blocks are getting smaller and smaller. So this is just to represent how much fresh water is actually available to us. This picture represents water stress regions from low to high according to color. And as you can see, countries located in the Middle East is predominantly affected by the scarcity of water. Also, some countries in Africa that is in a tan color does not have data that could be provided for this chart, so they could very well be stressed as much as the Middle East.
Hundreds of millions of people around the world depend on the use of underground rock formations, known as aquifers, to get the clean water they need. But a pair of new studies show many of the largest aquifers are being depleted at alarming rates. As seen on this map, of the 37 largest ones in the world, 21 are losing more water than is being replaced, with those areas in orange and red showing much more serious problems with depletion. These are located in countries like China, Russia, and Australia, as well as India, where water resources are already a major problem. The reports also identified declining levels for California's Central Valley Aquifer. Jay Famiglietti is a lead author on one of the reports from NASA's Jet Propulsion Laboratory, and he joins me now. Welcome, Mr. Famiglietti. Remind us, what is an aquifer and how does it produce the clean water?
An aquifer is an underground soil or rock unit that contains water in its pore spaces, and the way we get at that water is by drilling wells and pumping it up from the subsurface.
So, what did these two studies find?
We found that in the 37 world's largest aquifers that we looked at, that over 21 of them are past sustainability tipping points, meaning that the rate of withdrawal exceeds the rate of replenishment. And of those, we found that 13 are in a pretty bad way and threatened to exceed a point at which they may not come back.
And why is this happening?
Well, we rely heavily on groundwater, but yet we don't manage it very well. Around the world, we use about 2 billion people rely on groundwater as a primary water source, and it provides about half of the water that we need to irrigate agriculture. So we rely on it heavily, but we don't manage it very well, and that's true in the United States as well as around the world.
So is this depletion happening at a faster rate than it did historically?
In some places, yes. It's taken a while for the population in a particular region to develop, or it's taken a while for the infrastructure to come into place. For example, in northwestern India, the Green Revolution is something that didn't start until the 1960s and the 1970s. Prior to that, there wasn't much groundwater depletion.
Let's talk for a minute about where this is happening. We mentioned on several continents. Where is the problem the worst?
Probably the worst in the Middle East, the Arabian Peninsula, and even the region above the Arabian Peninsula, Turkey, Syria, Iraq, and Iran are regions that we've studied before. Northwestern India and really across northern India and into Bangladesh is in pretty rough shape. The North China Plain, the big aquifer system around Beijing, it is true, it's on every continent. The Pilbara mining region, which is the Canning Basin in northwestern Australia, Several of the aquifers in Africa are in rough shape because there's very little rainfall there in the Sahara Desert, so not very much replenishment. And in Argentina, the Guarani aquifer, and then of course the aquifers in the United States, the big ones being the Central Valley, and the High Plains or the Ogallala aquifer.
And what about the one in California's Central Valley? What shape is that in?
Well, that's in pretty rough shape. This study and other studies that we've done on the aquifer show that we've been losing about 5.5 trillion gallons of groundwater per year for the last 4 years during this drought, and that's because in California right now there's no snow in the mountains, there's no rainfall happening, there's very little water in our reservoirs, so we have to rely on this groundwater, and it's disappearing pretty rapidly.
Is there a way of knowing when this water is going, how much more water there is, when it's going to run out, and is there anything that can be done about this?
So that's an excellent question, and that was really the topic of the second paper. And so we tried to expose the fact that we really don't know how much water we have in the world's major aquifers. Again, it's true in the United States, and it's true around the world. We know that we're past these sustainability tipping points, and all kinds of ecological damage is occurring. And we know that the water tables are falling and wells are running dry. So I think it's very important that we think very carefully about exploring the world's major aquifers to understand how much water is actually there.
Well, it's a grim set of findings that I know a lot of people are going to be paying close attention to. Jay Family-Yeti, we thank you for being with us.
Thank you very much.
So this list is just some of the many organizations you can donate to. Also, if you're a more hands-on type of person and you want to physically help, you can definitely log on to one of these websites and sign up to volunteer. As long as people want to help them with their mission, they're willing to accept really anyone.